All right, we're going to go over section 3.5, which is isosceles and equilateral triangles. There are several theorems in here that I'll go through and explain. So open your book to page 156. And the first one we're going to talk about is the isosceles triangle theorem, which just states if you have an isosceles triangle, which is more than two or more sides are congruent, that if these sides are congruent, then the base angles right here, A and B, must also be congruent. If you were given information and proof that side AC is congruent to side CB, or simply that it's an isosceles triangle, then the next step in your proof would be to say angle A is congruent to angle B because it's the isosceles triangle. Okay, if you go over to page 157, you're going to have the converse of that, which just basically states if you have two congruent angles, then you must have two congruent sides, okay? And it's always the side that is directly opposite the angle, so you would draw little arrows like that from the angles, and it's the two sides that is pointing out. All right, so let's go through an example on here. They are telling us here that WVS, so WVS right here, is congruent to W. I guess it's asking you, is this angle congruent to this angle? You would say yes, because I see a little baby isosceles triangle right here, which means these two angles have to be congruent. Is segment TR congruent to segment TS? So if you kind of ignore these lines going in through here, and we have one big isosceles triangle, I'm doing RTS. If you see the mark right here at R, you just prove that S is the same. Therefore, the sides across, which is TR, and the side over here is TS, have to be congruent because it's the converse of the isosceles triangle theorem. So yes to that. Okay, let's come over here to this triangle. We're going to go through the examples on the page 158. It says VT, so if I come over here and look, VT must be congruent to VX. All right, so VX. All right, over here, UT is congruent to UW. All right, which is also congruent to XY. Okay, here VU, which is right here, is congruent to VY. Now the reason being, if this angle is congruent to this angle, those are corresponding, which means this side's congruent to this side, which means this angle also has to be the same. So VU has to be congruent to VY. All right, and angle VYU, so VYU is congruent to, oh gosh, you have all kinds of angles you can put. You got all kinds of options you can put in there. Anything that has the single arc mark. Okay, let's take a look down here. It's going to talk a little bit more about the symmetry that goes on inside of isosceles triangles. It says if a line bisects the vertex angle, all right, on an isosceles triangle, this angle where the two sides come together is called your vertex angle. So if you have an isosceles triangle and you have this vertex angle is being cut in half, which is what this is saying, then you know that is the perpendicular bisector to the base, which means it not only hits the base, D would have to be your midpoint, but it is perpendicular, which means you can automatically know there are 90-degree angles here. So let me talk about what that means. All right, if you have an isosceles triangle, all right, it has to be isosceles, and it has to tell you you have a line drawn down, and this angle has to be congruent to this one. This is your vertex angle. If this is true, both of these things are happening, then you know for a fact that this is hitting at the midpoint and it's hitting at a 90-degree angle. If this is not happening, then you cannot assume that. Okay, so you take a look here. Here's your isosceles triangle right here and here. This is being cut in half, which means it comes down here and hits at a 90-degree angle. So it is telling you angle A is 27 degrees. All right, so this is 27. You know this hits at a 90-degree angle. Same thing over here. Okay, 90-degree angle. This is 27. So in order to find X, you would just take 90 plus 27, subtract from 180 to get X, or just know these two have to add up to 90. So it should be 73, I believe. Nope, 63, my bad. 63. All right, so angle X is 63. You come over here, I see two different isosceles triangles going on. You have this one right here, so if that's 50, this one right here has to be 50, and 50 plus 50 is 100, which means X is 80. You come over here, if this is 100, these two have to be the same, so 100, take 180 minus 100, that is 80, which means these two both have to be 40, okay, because they have to be split evenly. Okay, down here you have some corollaries to some of these theorems. A corollary is just a theorem that can be proved easily using another theorem. So what it says here is if you have an equilateral triangle, now an equilateral triangle means all three sides have to be the same, then all three angles have to be the same. And then the same thing here, if you have all three angles are the same, then all three sides have to be the same. And remember, we had it on one of the homework assignments. On every equilateral triangle, it's 60, 60, and 60. All right. Okay, so that's pretty much it. Let's go through some of the lesson check here. You see an isosceles triangle, so you know you have two congruent angles. Find those at 70 and 70. It wants to know what is the measure of angle A. There you go. What is the measure of angle A here? If that's 53, this obviously has to be 53. Okay, that seemed pretty easy. Come up here, wants to know what is the value of X. This is your vertex angle up here. That is 30. These two have to be the same, so you'll take 180 minus 30. All right, which is 150. And then that 150 has to be split evenly between the two base angles. So 150 divided by 2 is 75. Okay, so X is 75. All right, if you come over here, here's that theorem. You have an isosceles triangle. This is vertex angles bisected, which means this is going to be a 90-degree angle down here. This is 42, which means these two have to add up to 90 degrees because 90 plus 90 is that 180. So this is 48 degrees here at X. All right, the measure of one of the base angles of an isosceles triangle is 23. So if you draw your isosceles triangle, knowing this is congruent to that, one base angle is 23, which means the other base angle has to be 23. And the question is, what are the measures of the other two angles? So one is 23. And then you'll add 23 and 23 together, which is 46. You'll subtract that from 180. And you get 134 to be the other one. Okay, so this angle up here has to be 134 degrees. Okay, your homework will be on Google Classroom, and if you have any questions, let me know.